My name is Gleb. I live mostly on the internet, on my GitHub, where I have hundreds of open source projects. You can find me on my website and on Twitter. And it's great to be here at OSCON. And this conversation is about JavaScript. And every time I program in JavaScript, which I have to do now, I feel like I'm playing Minesweeper, and at any second, the whole thing can just crash and burn and just go to hell. And how can you take a language that has this for equality table seriously? And especially inequality. Like what is this? This is a complete joke. And yet, we have to program because it's everywhere. It's on your browser. It's on your server. It's on your mobile devices. It's on your embedded devices, and even robots. So if you go down to an exhibition hall, you will see Cylon robots. And I guarantee that in a year, you'll have JavaScript in self-driving Teslas. And that makes, should make you very, very scared. And in 10 years, it will be in T800. And in this case, humanity quickly wins. That's actually a good statement. OK, seriously, a lot of languages kind of look down at JavaScript developers. I know I do, but a lot of people say, oh, you should use Scala, or Java, or Haskell, or Camel. But if you actually look at number of open positions, right, on Stack Overflow, JavaScript beats by order of magnitude all our good languages combined. And so what this means, plus, if you look at NPM registry, the amount of code released every day and updated every day and reused is just unbelievable. So this means that if we improve the quality of JavaScript development just by a tiny little bit, will affect everything in the world. And self-driving cars, that means will survive. OK, so I work at a company called Kensho. It's a financial analysis company. You can type, it's almost like a Google query where you say, how does cold weather affect price of banana stocks? Or should I buy Netflix when Feds change some kind of rate? And we answer it right away. And we're in Boston and in World Trade Center here right in the middle. And most importantly, we are on GitHub as well. We love open source. We open source a couple of libraries, mostly dealing with Angular. But also, we do something interesting. If we don't ban employees from open sourcing whatever they want. So if you work in your free time on something that you think might be useful, just go ahead and work. And maybe bring it back to the company and use it at work. Other companies, they kind of ban everything, and then they open source their own stuff. And I think that's kind of incorrect order. OK, so we have a website. That's how our clients use our service. They go to the website. They type something. It shows a whole bunch of statistical information, runs a whole bunch of queries, shows them the result. And we started from greenfield 2.5 years, almost 3 years ago. And everything actually was developing very, very quickly, right? Greenfield development, best tools, bright people, just code, just hack, right? Very, very quickly. But as time goes, this progress kind of slowed down, right? It became harder and harder to change things, harder and harder to actually fix something. And it's because number of developers, we I think reached 40 now, grew, so it became harder. And also, code accumulates, systems accumulate. So it became kind of hard. And so in our JavaScript that runs our front end, what we need to do right now is that to make sure that the code that we write is as clear as maybe English, or even better. It should always produce expected result. That means if I read the code, I should have an idea what it does, instead of the code actually surprising me in some kind of way when I run it. It should be simple to test. And also, if I write something very simple, and you write something very simple, it should be able to combine those two things to create more complex logic. That's our goals. And after discussing it, at length with other people that come from all different environments, we kind of decided to take two things and approach our JavaScript with these techniques. One is functional programming. So JavaScript might not be your typical functional language. Like Haskell would say, no, no, no. But functions are first order or first class citizen. You can create new functions. You can create high order functions. So we decided, hey, functional JavaScript is actually something interesting. And the second one is called reactive. And if you ever use Netflix, you've seen an example of reactive programming. Netflix is just one of the biggest promoters of reactive programming. And you will see what this means. So we decided, OK, let's take these two things, FP and reactive, and let's look what we have to do. So functional programming in JavaScript means write small pure functions, and I'll explain what this means. Compose complex logic from simple parts, just like we want. Kind of do async programming, not with callbacks, but with promises. And also kind of make decisions about the data simpler using immutable data. And then reactive programming is kind of very, very extreme approach. And it says every user action, like mouse click, mouse movements, button clicks, everything, is just a stream of events. Server actions, like server giving you a new result of a WebSocket, is, again, a stream of events. And these streams can be processed using kind of standard operations. OK, so this seems reasonable. And we're like, what do you want to do with my beautiful JavaScript code? What is this whole transformation? And these are smart people, right? It's not like some people who just started coding. It's not their first class in coding. If you tell, hey, the way you write JavaScript is wrong, use those two things, they'll look at you like this. And this is because we all come to JavaScript or front-end development or Node.js development from all different walks of life. So some people, like me, I come from a computer vision background, so C++, C#, CoffeeScript. Other people can come from other interpreted languages. And also, we do different things when we actually start programming JavaScript. So for example, some people can spend 90% on just JavaScript and very little time on accessing the DOM, CSS, styles, and so on. Other people might touch JavaScript just a little bit, but mostly work with styles and design. So it doesn't mean that I can take a junior developer, explain something, and they'll become, it's not junior versus senior problem. It's just the background, what you already know problem. And again, you can use JavaScript in different ways. You can touch front end in different ways. I'm probably somewhere like in this column. Other people like to use jQuery and CSS and so on. So it affects the style. So this means that in theory, I cannot just take anyone and then in a single step go all the way to what we want to do. That means that I have to take someone and go through a series of steps and explain, OK, you know how to solve this. Now, look at the next problem. And let's see how we solve the next step. And then from there, we'll go again and again. So the journey is long. It's not simple. There are obstacles. And due to time constraints, we're going to only look at highlighted things. So kind of our starting point will be procedural, imperative language, or style. And then we'll look at object-oriented, functional programming, move right away to asynchronous programming. And finally, we'll reach reactive things. And I apologize if I run a couple minutes longer than the schedule, but we're already skipping a lot. So all this aside, this was kind of like, these were our goals. Let's look at actual code. And the example we're trying to solve is very simple. I have an array. Array has numbers. I want to multiply each number and print results. So my expected result is print 6 to 14. This is something I would write when I just came from C++ world. Nothing wrong with this code. It's for loop. And the for loop does print number times constant. Nothing's wrong with that. No one's going to get punished or fired for writing this code. It's normal imperative code. I literally tell my environment what to do and how to do it. Yet, the for loop is just a pain, right? In C++, I constantly had exceptions when I wrote for loops. It's impossible to reuse this, right? Because I'm mixing multiplication and printing and iteration all in one piece of code. I can't really say, oh, this part just does that, and our part just does that. Everything is mixed in one place. Very hard to use in this case. So I started with refactoring. Well, my data is my data. OK, it's separate. And then I just write little functions. One multiplies numbers, another one prints them. Each one has one purpose. My rule of thumb is that if you're trying to describe a piece of code, a module, a function, and if you have to use the keyword and or keyword or, it's doing too much. It's doing two things. In this case, these little functions are doing a single thing each. And when my process number kind of combines the logic, combines these two. And then my iteration just calls that function. So this refactoring, let me see if I have this right. When I do this refactoring, my whole goal is to make each function as small as possible. And adapt maybe functions like multiplication to particular use case. And all I'm doing is progressing slowly through a code base, refactoring, seeing where I can extract small functions. And this code is boring. My goal is to take something that I wrote or someone else wrote, and someone tried to be clever and impress me. Or I do it sometimes. I try to impress others with my one-line Perl-like expression. When I refactor, I actually try to make the code as boring as possible. I try it so boring that people are like, why am I even reviewing this? This does this, that, and that. Why are you even asking for that? The problem is that if the code is not boring, it will surprise you. Because by reading it, you will not know what to expect. So for example, if inside your code you use this, that code will always surprise you. Like in this case, numbers for each function, this, this in this case probably means either undefined, if it runs in strict mode, or the global object. That's not what you actually probably meant. So using this is a huge red sign. So you have to do something like this, selfie. Actually, my advice is not to use selfie, just use selfie. OK, in browsers, the fact that console log somewhere inside use this will always surprise you. Only now I think they're actually fixing this. Using for loops always surprises you. Off by one errors, maybe the iteration variable was actually, you forgot to increment it somewhere. Maybe the size of array is growing or shrinking, things like that. Every time your function uses something that's not local to the function, it's not declared inside the function, or it's not one of its arguments, like something like constant that's outside, it will surprise you. Because when you try to refactor, you moved it, and all of a sudden that constant is no longer there. And that's the best case. In some cases, you move it, and there is another variable named constant somewhere. And all of a sudden, your code still works, but produces a completely different result. So the best boring functions that I know are pure. And the definition of pure means they only use the input arguments. They don't rely on any outside state, any outside variable. They actually never change anything outside when they run. Well, in this case, multiplication and print, they'll produce the same result no matter how many times you call them with the same arguments. And that's the best pure function. Print print, in this case, is not really pure, right? Because it actually modifies the output on your console. But for our purposes, pure enough. So just like boring people or boring parents make boring children, boring functions make new boring functions very quickly. And there is a built-in mechanism in JavaScript called function bind. And function bind means, let's say I have a function of 2 arguments, a and b, multiplies 2 numbers. If I know the value of the first argument, let's say I want to always multiply by 2. That means I know the value of the first argument. I can say multiplication bind. Null is a context, so don't worry about that. But then I can actually put the value. And it creates a new function. And it's the same as mul, but the value 2 will be at the first position. And you can actually provide more than a single value to bind more than just first. You can bind all of them, for example. But now I create a new boring function that just multiplies by 2 wherever I pass in. I can provide all arguments, and then it always returns 6. Kind of trying to be as obscure as not writing 6, but instead providing a function that returns 6. And this is called partial application. It's built into the language, but most of the libraries provide it for you. So lodash, underscore, ramda, they all implement that. And the cool thing about libraries that implement it, not the built-in, the built-in language only provides partial application from the left. That means first argument, second argument, third argument. But the libraries, they can do whatever they want. For example, you can partial right can bind arguments from the right. Spots, for example, library can bind some of them, but leave empty places that will come in later. Options bind, that means it can bind properties in an object. And heroin, don't do it, kids. No, it's just by name, injection by name. So you can say, OK, I like boring code. I refactored my code, lots of boring pure functions, but I need more. I come from Java background. I want my classes. I want encapsulation. I want inheritance, for God's sake. OK, well, JavaScript is actually object-oriented language. If you create a if you write a function and you use special prototype property, you can add methods. You can add more methods, for example, multiply, print. You can actually use the keyword new, create new instance, and then you can call set numbers, multiply, print. So the same language, same problem, but implemented in kind of object-oriented fashion. The only thing is that you have to remember that JavaScript is prototypical. So that means you need a function as a constructor, but you attach your methods to something called constructor name.prototype. And then you always have to use new keyword to actually create an instance to properly link everything. And in reality, the prototypical thing is very, very different. That means if you have an instance object and you have a prototype object. And if you're trying to call something and it doesn't exist, it will actually look at its prototype, almost like, well, I don't have it. Let me go to my mom and see if she has it. And you don't even have to do the prototypical thing. You can just create an object. And then you can use this object create and say, my prototype, like my parent, is this object. And it will work the same. And if you are really excited about ES6 or ES 2015 that introduced class keyword, where you can kind of mimic classical, not prototypical, but classical thing, just don't. It's pointless. OK. Aside of my personal opinion, my observation is we work with lots of data. And most of the data is pretty much just a list, right? Same objects, and we have to do something to those objects. And JavaScript arrays are great because they are objects. And because they are objects, they have a bunch of methods already provided for you, like map, filter, sum, for each, and so on. So for example, if I take my numbers and I take my little pure functions, I can create multiplication by a constant on the fly. And then I can just write numbers, map multiplication by, and for each print. And to me, this combination of functional plus object-oriented stuff is great. Because I think this expresses what my algorithm does very, very clearly. So map is built in, just like filter, sum, and a bunch of reduce other methods. And even for historical reasons, when it wasn't part of a standard, the libraries already provided these methods, right? So for example, if you take a library like Lodash, it has map. And you pass your array and your callback. But it also has a bunch of other methods, like group by, drop while, filter, take, like lots of ways you can work on your arrays. And if you look at NPM, huge registry of modules, and you look at what are the top 3 projects that every other project kind of imports, 2 out of 3, with the top one being Lodash, are these libraries of little functions that operate on lists, on objects, like all these little functional utilities, which is amazing, right? We all are used to thinking, oh, JavaScript is just this front end, touch element, jQuery is the top dog. No, it's this little functional programming that's the top dog in JavaScript. OK, so we can work with arrays, for example, using Lodash library. We can do partial with our functions. We can take our numbers, multiply by a constant. We get another array, and then for each, we print it. The cool thing about these library functions, instead of just working with arrays, you can work with objects. And then you iterate over properties. Kind of cool. But then you really have to think carefully about what you write. So you write functions, right? That's your API design. My function multiplication was called mul, and it had A and B in that order. Lodash, for example, says map, takes first array, and then the callback, multiply by. Other libraries said, no, this is wrong. Instead of doing that, put your callback first and array last. And this allows for a very interesting trick. Let me show you this. So first we'll put multiplication, callback, and then array. So if I multiply by a constant, I create by constant function. If I take map and I put whatever I just created, the callback, because it was at the first position, I can create map by constant. So I take my functions and I create new functions that will iterate. But nothing has been executed yet. And then I can say for each, and callback print. And then map by constant, and only now I provide the actual data. Because my data is at the last position, and I kind of applied arguments from the left because they were known, they were callbacks. I could create this line, and only then it actually executed. And if you look at this line, it's a function called on the result of calling this function on the numbers on my data. And in math, this is very standard thing. It's called composition. I can replace f of called on g on x with something together. So this compose utility, it's in every library, Lodash, doesn't matter. And it takes print, map constant, whatever I call here, and it returns you something new, a new function. OK? And then you can call this function on your data. So we got to this thing, like the whole kind of massaging of all arguments, putting them back to back, composing them. And once you get this, you get a function, and you call it with data. And if you can take your whole code and express it as function that will be called on data, this is extremely simple to test, right? Because you just give different types of data, and you check the outputs. So how does it look in practice? Well, first, there's another thing that we can do in JavaScript. Well, if we do partial application, that means provide values, well, we have to do it as a client. That's kind of if I do it every time, why don't I build this partial application into the function itself? And this is a query utility. It takes any function, and then it converts it into a function that will just wait until it gets all the arguments. So for example, multiply will be 5. Oh, I need the second argument. Oh, you got me 2 arguments, so I'll just execute. And so it's built into Lambda. Everything is queried. It's called query. And this is how it looks if we program it in Lambda. This is how a lot of code at kensho looks like. It's all queried. It's just a pipelining of all my functions, but because they're known, and only at the end, we actually give it the data, and it processes the data. So first, I looked at object-oriented way, right? Kind of, yeah, it's OK. You know, we have smart objects, but we have methods like add, multiply, print, and so on. I had to program over and over again, standard Java stuff. And I passed kind of dumb data around, like 317, 2, right? So my object number multiplier was smart. My data was dumb. But in functional programming that I showed after that with arrays, well, the objects are really dumb. It's just an array. It had no logic, almost no logic. But the pipeline that I created using my functions by composing them is pretty smart. And I passed functions around. I said, map numbers by constant. By constant is a function that I passed around. I passed the behavior easily. Alan Perlis, who created a language called Algol, one of his Perlisisms, and he was like Yogi Bear, right? He had, like, if you go to this link, there is like hundreds of these little funny computer science expressions. He said it's better to have 100 functions operate on a single data structure. And a single data structure, I think he meant a list, is better than to have 10 functions operate on 10 different data structures. So instead of writing 10 different things with 10 different methods, just write more functions that operate on lists and pass a list around. OK, so let's shift gears a little bit. You know, in JavaScript, everything is mutable. If I pass you an array or pass you an object, you can change it. And then I don't know if the object has been changed or not. So it's kind of hard to reason about things. You know, there are libraries that make it immutable. You know, Facebook has one. Everyone has one. And we actually do it very, very efficiently. So you don't have to worry about those. But the conclusion is that arrays are great for synchronous data. Like, all my functions were like multiply, print, done, right? No callbacks, nothing. They completely cannot handle asynchronous data, right? For example, if my map function, if it actually used a callback, if it didn't execute right away and return a result, arrays don't know how to handle it at all. Like, it would fail. So we need something better, right? So how do we do that? And the part of new standard are promises. And even before the new standard, there were libraries that actually gave you promises in user space. And for example, I used to use this library Q for a while. Promise is just a wrapper. It will hold a value eventually. But instead of giving you that value right away, you provide a callback saying, hey, whenever you have the value, call this function for me. And this makes a lot of boilerplate go away. Error handling is much easier. Promise for single asynchronous action is the top dog. You can combine them in a pipeline, return other promise, so you can chain multiple asynchronous things. Just great. But the problem is there's still a lot of boilerplate. So for example, in this case, I multiply all these numbers, and I delay by 1 second in between. And you can see that it's hard to actually understand what's going on. Right? Like, what is that function? Like, it just sleeps for a second and then continues? Like, the problem is that we're writing a lot of boilerplate because a promise can only be used once. Once it's fulfilled, that's it. So in reality, a promise is like a bullet. You fire it once, it's done, it's spent. So we need something more, right? We need something where we can chain multiple asynchronous pipelines, but without extra boilerplate. And the good thing for this are event emitters. So these are things that do something for asynchronously and then fire off an event saying, hey, I'm done. Here's the next thing. And they completely decouple what produces a thing to who's listening. It's literally your observable or subscriber pattern. And they're used everywhere. So if you subscribe to Click, it's an event emitter. If you subscribe to Resize or Socket, so they're used over and over again. So we can extend the same approach. And we can say, well, our number is not going to be an array. It's going to be something that's emitting a number at a time. And so we can say, well, every time number emitter emits a number, we're going to multiply by a constant and then print. Again, I'm reusing the same little functions. Once you write them, you can reuse them in any kind of pattern you want. And so here, I set the interval, and every second emit a number, and my processing happens. So this prints numbers with intervals. So that's nice. But if I look at the code and I say number emitter on number and do action, like what's the meaning of on, right? And how do we connect multiple steps? That's my goal, right? Do something else, and so on. So when we had an array, we had map, clear semantic. Take each number, multiply or something, return me a result. So map took one array, return an array. For each, just executed this for each. So every member had a clear meaning. So what we really want to do with our code that models real world is to have a source of events and then map and call asynchronous function or any kind of function. Maybe we want to buffer, right? Maybe we want to say multiply 2, 3 numbers, and then give me the whole list at once, and I'll print it. So we want that. So really, we want to create a pipeline. So the first step will be a source. When we map, we'll add one more thing to the pipeline. We haven't executed anything yet. Then let's say we want to buffer 3 items. We added it to pipeline. And then we say, for each, do something. And for each is kind of special case. That means we're done. Because for each doesn't return anything, we're saying, well, whenever there's for each, stop building a pipeline. Now you can actually execute things. So let's say source gives me a number. It goes into map, calls a function, multiply, goes into buffer. Buffer says, well, I need 3 items, so I'll do nothing else. And then 1 arrives, gets multiplied, goes into buffer, still not full. Great. 7, 14. OK, buffer is full. Now it actually can pass things down and print them. So building the pipeline with emitters is actually not that difficult. We just have to, let's say we want to implement map. Well, we'll just have a method map. It will actually return an emitter itself. So it's like emitter emitting an emitter. The code, whenever some number arrives, multiplies and then emits to whoever's listening. So kind of one listener does something, emits it to whoever's listening. We can implement the buffer again, kind of the same approach. But when we look at what we've done, we have map, we have buffer, we have for each. Map was a data transform. Buffer is kind of different. It did not transform the data. Instead, it kind of controlled the action flow, right? It kind of waited for a couple of events and then generate a new event. So it's kind of like maybe time or sequence control. For each is simple data transform, just print. So literally, we have to write a bunch of methods just to control the timing or sequence, right? And this is exactly what reactive programming. We just wrote reactive programmer. So let's take a step back and think everything that we might think of is a source of events. In this case, it was numbers. We just built a pipeline, right? So we built a pipeline, and then we started it, and it executed everything. And typical libraries in Rx, like Rx, Bacon, Extreme, they have the standard operators, just like arrays, but they also have a bunch of extra methods for controlling, timing or flow of events. For example, buffering, or zip. Zip meaning like if I have a bunch of streams, I want to create a stream of combined results. Flat map latest, and so on. And here's a typical use. Let's say, again, I want to print all these numbers after multiplication, but I want to print each number one at a time each second. So I create first stream, and it's going to be an interval of 1 second. So every second, that stream generates an event. Timestamp, timestamp, timestamp. Well, probably no. It probably goes like 1 Mississippi, 2 Mississippi. I'll take my numbers, and I'll create another stream of numbers. So it will generate first number, second, third. And then I'll just zip those. And I say, well, take the first stream of timer events and the second, and just return second. So this is kind of cool, because now with these three simple steps, I'll get a number every second. And then I can map by a constant and print. Again, I'm reusing the same functions, but now I added time information. Kind of powerful. Even more powerful that instead of this, which is kind of like artificial example, I can create click events from my DOM, from my UI. So now I'm going to print a number multiplied every time someone clicks a button. Kind of cool. Nothing here changed. Only the first stream became a click stream on a button. People usually show what's going on with all these operators in Rx using what's called marble diagrams. So each stream is a line going from left to right. The events are showing on a line. In this case, the first stream has different shapes, and the second stream has different triangle with colors. My zip could be really advanced. In this case, it takes the shape from the first stream, but the color from the second. And it outputs a new stream of events. So you see these marble diagrams over and over. People now are really tricky. They even take the marble diagrams, and instead of writing unit tests, they just write like marble diagram in text. And the test runner just executes those. Kind of cool. OK, example, everyone who talks about reactive programming has to use this example like it's the law. It's not my idea. So let's say I have a method that searches Wikipedia, returns a promise. OK? And let's say you want to implement like type ahead. So user is typing, and then it goes to Wikipedia and shows results. But you don't want to go to Wikipedia and do a search on every character, right? You want at least a couple characters. You want to throttle. And most important, you want to handle out-of-sequence results. Meaning, if you search for A on Wikipedia or Google, it will actually take a lot longer than searching for Apple. That means if you execute a search when a user types Apple, and you execute a search on A, and the second search on Apple, the Apple result will return first, and then the result for A will return. So you want to ignore whatever previous search was. So here's how easy it is to do with reactive programming, because the mental model actually suits this kind of task. Well, we're going to create a stream from the input field. Every time someone presses a button, it will fire an event, but we'll only take strings that are longer than 2 characters. That means we're not going to search for A. Maybe apapa. And then we're going to throttle the stream. We're not going to search for the same thing. So if you added a character, deleted a character right away, not going to execute it again. Flat map latest means disregard any previous searches, even if they come out of order. So always take the latest. Subscribe you get the data results. That's it. Your whole kind of normal type ahead implemented with just a couple of operators with a standard. OK. And I want to close with one thing. So we talked about pure functions. And I want to show how you can preserve purity for a whole application. So add a, b, just return a plus b. Never used any outside state, never change outside state, just return a plus b. So if we take a couple of functions, right, and let's say it's like a, multiply, subscribe, or subtract, they all were pure. If we compose them into one algorithm, well, the result function is also pure. And the question is, can we actually take the same approach and keep building this function, keep building until we get the whole application, right? Sounds like something Haskell people would be interested in. Well, here's a trick. So let's say we wrote something like this. Main function, that's our application. And we said window.title equals hi. Well, we just used outside state, window, right? It wasn't even a variable. And we changed it, right? We changed it. So that means it had side effect. And every web application has to have some side effects, right? Otherwise, it will run and you will never know because it hasn't done anything. But here's the loophole that we can use. So let's say we write main. We have the title. But instead of changing the window title right away, we return a function that actually does it for us. Right? Well, what happened? Our main function is actually pure. Only the function it returned is actually dirty. So it's the same as saying, like, your friend calls you, like, hey, I've got this, car that I got somewhere. You want to, strip it for parts? And you're like, oh, I'm not doing this anymore. But if you call this guy, right? So it's exactly the same principle, right? You're not doing the dirty work yourself. You're returning a function that will do the dirty work for you. So that's how it runs. You call your function. Still, everything is fine. No dirty work. Boom. Now it became dirty, because the dirty function actually ran. Even better is to pass the window as a variable, as an input. Right? So you're not accessing like all global variables all over the place. Still the same principle. And there are now frameworks that actually take this to an extreme. For example, cycle.js, you write a function, and as an input, you take this object, let's call it DOM. And the DOM is just a bunch of streams that give you all the inputs from the DOM. Like, you can subscribe to like key presses, button clicks, resizes. So you're not doing it directly on a DOM. Instead, you only use this DOM object. And you return an object where you output a stream of DOM updates. So you're not updating the DOM itself. You're not saying, OK, put h1 here, input box here, and a button here. You're saying, well, no, I'm just going to fire an event that will do that. So you preserve the purity everywhere inside your main function. So it's all pure. And when the cycle runs, when it actually creates those wrappers, when it actually sets this up, only then your application starts actually looking at the DOM, touching it, updating it, doing HTTP requests, and so on. So it's kind of a big mental shift, because you have to program in a completely different way. You have to think about, am I actually touching outside state that I should not be? Am I only using the input arguments? And am I outputting something that will not change things directly? But it's possible. So in conclusion, the best thing you can do right now is to start splitting your code and write as many small functions as possible. And once you produce a lot of small functions, you will discover that a lot of those functions are actually the same, and you can be reused or could be actually used directly from a library. And if you concentrate on only using the input arguments to generate something, when your function will be pure, and it will be just so easy and simple to test and reuse like nothing else. If you want to handle single asynchronous function, use promises. That's the best advice. Don't use callbacks. Promises are the way to go. But if you have multiple actions, multiple asynchronous steps, look into using an actual stream. It's called observable or RxJS, whatever you want to call it, but use an actual event stream. The future is very bright, because everything I showed today is actually available. It's all part of current standard or user space. ES6 will make some things easier, but it will not drastically change anything, really. So you don't have to wait for something else. And finally, I want to thank you guys for listening to me. All the slides are here. But most important, I wrote a blog post with all the links to every topic and explanation. So you can actually take these slides as a starting jumping point and go and explore every topic. And Kensho loves open source. And please rate this, go and rate this presentation on OReilly conference app. And maybe say that you're not afraid of T800 anymore. Thank you.